or you may start.
All right, Daniel. Your problem is going to be flattening a binary tree into a linked list. So you're given a tree that follows the properties of that is a binary tree, so two nodes, and you want to flatten into a linked list. So basically, each node only points to one other node. So it'll no longer be a tree; it'll be a linear traversable data structure.
Okay,
Go ahead.
and this is gonna be in like ascending order, right?
So the order will be the same order as a pre-order traversal of the tree.
Okay, a
So
pre-order
in this
traversal.
example here, are you familiar with a pre-order traversal?
Yep.
Okay, so then I want
And
to explain it to you. Starting at a head pointer, you want your final linked list to be in the same order as a pre-order traversal of the binary tree. And you are
okay.
given this struct of the tree node, and that is your definition of the tree node class. And you are not creating a new linked list. You want to be using the same nodes as those in the tree.
You might be sharing the wrong screen because I see reverse a stack with using a queue.
Oh, you're right. I am. Yeah. Let me fix that. No. Oh, no, 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 no. That might be bad.
What's wrong?
I accidentally opened another tab and I think it might have closed. Oh, no, we're good. We're good. LeetCode is back up. Okay, I will stop this sharing and start sharing the correct tab. Okay, can you see it now?
I do see it.
Okay. Okay, so in this example, you are starting with this binary tree and you are ending with this linked list, knowing that these are not new nodes. You are still using the same tree nodes.
Oh, I see. There's
Any
no
more
like
questions
linked
about
list
the
going.
problem?
So, okay. I believe I understand.
So something I didn't say, the left pointer of each node in the final linked list should be null or null pointer.
Yeah. Yeah. By any chance, can you copy and paste like what you have into the chat so I can just start doing that from the Google Doc?
Um, if you want here, I can give you a link to the problem. I think that's fine.
No, it has to be on a Google Doc, unfortunately. I just want the like the class solution one, like lines 12
Yeah.
through 17.
Do
I
you
just don't
have
want to
a
erase it.
Google Doc made?
Oh, you don't have to copy and paste that part. Yeah, I have a Google Doc. Just
Uh,
the
wait, send me the link and I'll paste what you want in there.
yeah, I think I need your email for that, but it's okay.
You could just send me a link or whatever.
Yeah.
Which part did you want?
I wanted lines 12 through 17, but it's not that big a deal. It's okay. I sent the
Oh,
link.
okay. Um,
Did you get the link by any chance?
yeah, 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 yeah. Can you change the link for edit access? Like when you click on share, it should say like copy link and then like viewer, editor, something like that.
I changed it.
And then can you send the link again? Here, let me just paste it as text. There you go. Is that good?
Yeah, that is
Okay, I
completely
will stop sharing and you can go ahead and share.
right. All right, can you see it?
Yep.
All right. So, the idea I have is I'm going to create another function that the flatten function calls, and this where put the preorder traversal in a vector passed by reference. So I have all the values saved. Or use a bit more space, but I have all the values I need, and then I'll go back into the flatten function and put each thing from my vector into the right root and keep doing that until the end of the vector.
Okay, go ahead.
Or just write that out. As reference. This will have two parameters, the tree root and the vector.
If you want, you can assume you're using namespace. So you don't have to write out the std double colon.
That it's all right.
Okay,
I intentionally didn't put like namespace. I like to know when I use from the STL library.
fair enough.
And they are ints, correct?
Yeah, they're stored as integers, but let me double check the class the struct definition for you. Yeah, they're saved as integers with the name val, VAL.
Okay, I appreciate that. Yes. I'll use camel casing. All right. And now we have to do I'm going to push back every value that I can in this while loop or make sure I'm not accessing a null value. And I'm putting this pushback before I call the left and right because for pre-order, or put it up here. it goes node, then left, and then right. Therefore, here, and I'm going to change this void to a tree node so I can keep calling itself. That's a mistake.
So you are creating a vector that
Yep,
you are then going to use in your flattening function.
that is correct.
Okay. Where is the vector going to be initialized?
The vector is initialized and flattened,
Okay.
as if you can see
Yeah,
where
I
I'm
see it.
highlighting. That's where it's created. So then I can pass it into get pre-root.
And it is a vector of integers, right?
Yep,
Okay.
it is a vector of int. Now this should get the pre-order traversal if my memory serves me right. And now I guess I could ask, does this look about right for getting a pre-order traversal for a tree?
Yeah, that does look correct to me.
Okay, cool.
But I will remind you that the final linked list needs to use the same nodes as the initial tree.
Hmm. Okay. Then I just have to change this vector from ints to tree nodes.
Yeah, I think that would be helpful.
Tree node, I call it node. I appreciate that. Now, does this tree node class have its own destructor?
I think for our purposes, you can assume it does.
Okay, I appreciate that. Yeah, that's definitely something I didn't think about that I have to use the same nodes. I have to reprocess a new way. Let's see. Mm,
This may be syntax I'm unfamiliar with, but why are you including a name within the vector type?
and where are you saying this?
Both places you have the vector. You have tree node pointer and then a name node.
Yeah, I guess. No, that is correct. I appreciate that. I believe that is correct, at least.
Yeah.
Okay. I appreciate that foresight. I believe you're right. That should not have a name. That is just what type it is, and it is a
Yep.
tree node. It is object of tree node. Okay, now let's see. I'll push back all these nodes. Now we're back to the flatten function. I could create the delete function quickly
If you want to, you're more than welcome to.
because I'll just delete it in a post order traversal. Or actually create another function for that. Just another element. Move this to here. I'm going to call the delete because my thought process behind it is that I'm not gonna move around all of these nodes, even though that would be more space efficient. I'm going to delete everything, which will be O of n, but the overall time complexity of this is going to be O of n anyway. So
Um, can I ask why you want to have a delete function?
I want to delete all the nodes. Wait, can I? Well, yeah, I can delete all the nodes because I have all the nodes saved in this vector that I already pushed back in the pre-order. So then I can just replace the tree with the nodes that I have in my vector.
Um, I will say that won't work because your vector is pointers to the nodes, and if you delete the nodes, then the pointers will not be pointing to something that exists.
Huh. Haven't thought of that. Not sure. I appreciate that foresight. I would have had to use the new keyword. Is that what you're implying?
Um, so you're saying you're going to make this vector of
Yeah.
tree node pointers, and I think by definition, for you to be able to access them outside your get pre-order, you're making pointers. So no, I don't think you need to use the new keyword. Um, because the vector is realistically just storing integer values that are pointers. Um,
Where it is just storing like nodes.
it's storing pointers to nodes,
Yeah.
which are just memory addresses. So, but what I am saying is if you delete the things that are being pointed to, then when you try and get their value or something, there will not be anything there because they've been deleted, even if the pointer still exists.
I see. I did not see that in the foresight, so I'm gonna have to get away to rearrange all the pointers in this tree. Hmm. I'm going to try to just make the tree with the vector that I have and just set all the lefts to null while I'm doing it. It might not be
Okay.
correct, but that is what I have at the moment, and you can tell me at the end. But for now, that is what I have
Okay.
for a solution. Oh, there's a way. There you go. You have to backspace to stop the.
Gotcha.
I'm gonna make an integer just for the size of the node, and then do a for loop. I could use a while loop. What a for loop for the amount of nodes there are, so the amount of times I would do this process.
I'm sorry to stop you, but I realized an error I made. when you asked about your pre-order traversal.
Yep,
Uh, so what you have is save dot pushback root. So that's going to push the node into the vector, and then you
yep,
want to push in the left and then the right, right? Uh,
yep.
but why are you saying root left pointer is equal to the pre-order traversal of root left pointer?
Or that's just how I remember doing it in my AVL project, but it could be without this part. I'd have to double check, but it could very easily just be without this.
I think what you want to do is in your first line where you have save dot pushback root, um,
It
it
should be node.
yeah, because you're calling it node. You're right. So you're gonna save the node and then you're gonna do a recursive call on node dot left or root dot left, right? And that'll become your new root.
Okay. So you don't believe I should do root dot next here?
Mm, no, that's not what I'm saying. I think the issue was what you had with setting the like left node equal to the get pre-order of the left node. Um, because I know the C++ compiler will let you do a recursive call and not have the return value be equal to something. So this is legal syntax, but I'm not sure if what you had before was setting root left equal to the return value of root left uh, on the pre-order would have worked.
I think I can do this, but this function would just have to be void.
I know that you can do it without it being void, but making it void would also work. Um, yeah, making it void would also work.
Okay. I just know I've done it before, at least for quizzes, like
Yeah,
the
yeah,
root
yeah.
left and do this and it. I don't know, it works. I guess there's different ways of doing it, but I'll definitely double check after this. I appreciate that. Continuing with this, I'd have what I is less than size. The root will stay. No, it won't. That's the yeah. I'm gonna make the root before I go into the for loop, and I'll show what that means in a second. I'm gonna have a catch if size doesn't equal to 0, because it's a possibility that could be empty. I'm not gonna get a sig figure. Do size -1 since already one of them is done. Here we're gonna actually not have size -1 and keep the index at 1 because I already use index 0 for node. For here, I would make root right to node of the iterator to go through the vector. And at the same time, just making this null and hoping for the best. Root left equals null. You keep going with that. Hopefully not deleting anything. And then by that, we should be able to go out. Let's say the pre-order traversal was something like this. Okay, one, we needed four more. Go through. This is size 5. Well, this would happen 4 times. And that is probably the best I'm gonna get at.
Okay. So for your for loop, you say root, the right pointer from root is equal to node of I. So you've defined root to be the first item that you have in your vector, right?
Yep, up here, right above the for loop.
Yeah, so that in this case would be 3.
Yep,
And then root right would now point to to node 1 in your vector. So it would
yep.
point to 3 right would point to 2, and node left would point to null. So that seems good so far. But then you increment I and I equals 2, and your root is still 3. And so 3 right is now going to point to node of 2, will be 5.
Nice. I see what you're saying.
Yeah.
I have to keep going. Yeah. I have to keep going, right? Hmm. I don't know why in my head the only way I'm thinking of doing that is doing that recursively. I don't. What is a way? What is a way of just keep going, right? Oh my. I or in my head because I only know one way of doing it. Not experienced enough.
Describe to me what you want to do, just broadly speaking, not with code.
Like to keep going down the route because you brought up a very valid point. I didn't account for that. Is that and the only way I know of like going down like a tree is recursively. It's like root right and just keep going root right. And so I believe I'm gonna have to create another function and pass
Well,
that vector in and just keep doing the same thing this for loop's doing, but then keep calling itself on the new route that goes to the right. And
you could do that, but I don't think it's necessary. I think you've done all the work that you need um, with your pre-order traversal. I think you can do everything you want to with the vector you've created. Um, Keep in mind that the vector has pointers to all the nodes you want. Um, so you don't need to like find the nodes again because you already know where they are and what order you want them in.
yeah,
If that
I
makes
just
sense.
yeah, that makes sense. I just don't know how to keep going down like root right. I don't know how to keep going right.
I think you have to do
Oh
two
wait,
things for loop.
I wait a minute. I maybe I could after uh, that's so it can keep going right, but it'll
Yeah,
just keep making a new route. Or
I think that would work because now run me through your main function. You can ignore the pre-order helper function using the example you created.
So I have a vector that is pointing to the tree nodes, and I got that taken care of with this function. I got the size of the function, so just to simplify the code later, and make sure the size isn't equal to 0, because if it's equal to 0, then the list is empty and we're done. We don't have to return anything or do anything. Just make sure you don't get any sig fig errors. So if that isn't the case, size could be 1, and that would just get taken care of by root equals node at index 0 from the vector and be done. But if size is 2, then it'll go into the for loop or greater than 2, and it'll make root right equal to node at the index I starting at 1, because we already took care of index 0. And while we're doing that, we're making root left null, because all the root lefts should be null, and making root equals root dot right to keep going down the non-recursive way.
Okay, so now what is root equal to after you've gone through the for loop once?
Root will be equal to 2 here after the for loop's gone once, because root
Okay.
was free, and then root is now equal to root right, so that would be 2 going through this again, and 5 would be root right, and then that would become the root, so that would be 5, and then again the same for 7, and at 8 it should do it, and at 8 is the root. Let me go through it. 1, 2, 3, 4. So yeah, we won't get a sig error. This will only happen 3 times, the way I have it set up.
Why does it only happen 3 times? Just like imagine we are at 7. 7 is the root. Can
Yeah.
you step by step go through that case for me?
If root is 7, and that means I is 4, and 4 is less than 5. So we're
It
execute.
is I equal to 4?
If 1,
Um,
2, 3. No, I get what you're saying. I'm just trying to think of it in my head. If 4 is I, no, if 7 is I. To be index, I is 1. Sorry about this.
no, no worries.
I is 2.
Do you mean to? Oh no, keep going, keep going.
Because obviously in my head I'm not doing it right. Yeah. I would be free when it's looking at 7.
Okay.
And size is 5, so that would execute.
I'm gonna go through this, okay? So we start off with root equal to node 0. Node 0 is 3, right?
Yep.
Okay, so then we go into the for loop and I equals 1. So root right is now going to be equal to node of 1, which is 2. So 3 right pointer is now 2. And then root left is equal to null. So he has a left pointer to null and a right pointer to 2. And now root is equal to root right pointer. So now our root is equal to 2. And we're going to increment I. So now I is equal to 2 when 2 is your root. And then we'll go through that again. I will now be equal to 3 when 5 is your root. And then we'll go through that again, and I will be equal to 4 when 7 is your root. So you were correct the first time.
Okay.
Yeah. I the
What?
little trick that you did with having root set up outside the for loop, And then having your index start at 1 is good because that will prevent out of bounds errors.
Yeah, I was trying to make sure like at 8 it won't get like a sig fig error because
Yeah,
at 8
because
I would be 4 and that
I
would
don't think so.
execute.
I think when 7 is your root, I will be 4.
Okay. Oh yeah. This is all off by 1. Yeah. 7 would be 4. Yeah,
Yeah, and so it'll
I
go.
overthought it. I
Yeah,
was
you were correct. Root right pointer will be 8. Root left pointer for 7 will be null. And then root will be equal to root right. So now 8 will be your root. The for loop will end, will increment I. I will equal 5. Your size is 5. And so it will no longer be less than size. And then your program will terminate, I believe.
okay, cool. So I think that is the end of I think that's my solution.
Yep. Out of curiosity, your solution is good. The lead code did give bonus points if you could figure out an additional space complexity or a solution with additional space complexity of O of 1. Anything pop into your head?
You just have to rearrange pointers somehow. Since you
Yeah,
couldn't keep them in a container. It would
yeah,
just be a way I haven't seen yet, but it's definitely possible. You just have to rearrange pointers correctly.
yeah. I think that's correct. My solution when I looked at the problem was very similar to yours, except instead of using a vector, I wanted to use a queue. But that doesn't really matter. It's semantic differences. Um,
I need
so
to get
yeah,
into using views more.
good job.
So, and I say this is O of n, final time complexity, because we
Um,
go through everything in the pre-order, and I go for roofing again. So it would be 2n, but we don't care about constants. It would be O of n, and
yeah,
n being the amount of nodes. Yeah,
yeah, that would be
that is
correct
it.
time complexity.
I appreciate it. I'm gonna stop the recording.
Yep.